Hello.
Hello.
Yeah, I'm able to hear you.
Okay. I think you can start the recording.
Okay.
Okay.
Done.
So the collections is one of the important topic. If you remember, like when we are discussing about arrays, we were discussing about some limitations, right?
Yeah, disadvantage. We can't extend the memory.
Yes, we cannot extend the. So if you want to have the more space for the more number of elements, which is not in your control, because at the time of declaring array, if you ask for 10 blocks, it gives only 10 blocks. You cannot extend beyond that. If you want something, you need to go for something new, right? Automatically on the fly, if you want to have like unlimited number of things, which cannot be possible at all. Arrays. Any other limitation which is having?
Only that limitation, right? We can't extend the memory. The main disadvantage.
And one more thing we have discussed. Homogeneous. If I declare my array as integer, I can only store integers.
Okay, yeah, homogeneous, yeah.
So if I declare my array as something else, only that particular data type I can store.
Or we can store only a particular data type, what we mentioned. Okay.
If you store integer, so it's an integer variable, right? If I declare integer variable, can I store string? Yes, right? Obviously it won't act.
Yes.
So with respect to collections, like we can store any kind of like data type because it accepts in the object format. Almost all are from the object, right?
Yes.
So we'll get into the details of based on the classification of the uses. They have classified into various levels. So primary thing is list and set, and we have map as well. So first we'll be focusing on the list, like what are the various lists which are available. Okay, these are the three lists which are available. ArrayList. ArrayList means basically it is like entered. All the list elements, if you want to, let's say you have a requirement that I would like to store elements in my collection, and my elements I can store any number of elements in my collection, and there is no limitation of like here you can act if you want to store a duplicate elements as well. Okay? And these are the kind of requirements like should allow me duplicate elements. Okay. Allow me like any number of elements. And the way of retrieval and everything should be faster, then we need to go for this list. For example, if you specifically focusing on the array list, what happens is like, so whenever
in collection we do have this array list, vector, linked list, everything, right?
Yes, exactly.
Okay, in collections we do have that list. Okay.
All these are part of from the
java.util package.
So anything that you are working on here, you need to import from the respective class or interface from the java.util package. Okay. Almost all. Without importing them, obviously we cannot put them.
Okay.
When you declare an array list, what happens is initially it allocates 10 blocks of memory for you.
Okay.
If you're not giving any array list size. So in the arrays we give a size, right? So the array list we are not going to give us. So we have an option. So one of the options is if we are not giving any size. So that means declare a variable as array list equal to. This is one of the constructor. Okay. sorry, array list. If you declare your array list as with a default array, then initially it gives you a memory block with a 10 space, 10 blocks. So
Okay.
that means it has given a room for 10
Hmm.
blocks. So you can keep on adding elements up to the 10. So as and when
Okay.
you reach up to certain calculation,
Hmm.
immediately it allocates some more space for you. That means if you completed around 10 elements, so it identifies that internally that this is like my array list, whatever initial size is being allocated for me is being occupied. It immediately it allocates for 50% of it. Means currently its size is 10, right? Internal size.
Hmm.
It allocates 50% means 5. Means 10 plus 5, 15 blocks it's going to allocate.
Okay.
Okay. So as and when those 15 elements are from block, so full. So what is the 15 by 2? So around 7, right?
7.
So
Yes.
15 plus 7.
Hmm.
Like that, it's going to increment its size as and when to keep on adding the elements. Okay.
Okay.
About how the memory allocation happens internally. By
Hmm.
default, if you're not giving any size specification,
Hmm.
there are certain cases that I don't know size, right?
Yes. Hmm.
I might give some which is default. So
Hmm.
default it's going to give us 10. So
Hmm.
keep on extending based on your requirement.
Okay.
There are certain cases that I know that 1000 elements are required.
Okay.
If you know that 1000 elements are really required, simply you can pass the initial size as 1000.
Okay.
The difference is what happens here. If you give initial
Hmm.
size as the size what you already know, it gives you
Oh,
1000. It allocates you that many blocks in the memory.
okay.
Okay. The previous case, what's happening?
We didn't initialize the size.
So here given only 10, right? If you have
Hmm.
not given anything, any size specific, it has allocated 10. So
Hmm.
multiples as and when you are reaching the size of elements, it's keep on extending. So the
Okay.
here internally, it's going to take a lot of effort. Means first
Hmm.
how it's going to 10 elements are full, right? As and when you reach 10, it has allocated a 15 elements. So all the
Okay.
10 blocks are already assume that this is 10 blocks.
Hmm.
B1 to B10, suppose. Okay, blocks.
B1 to B10. Okay. On
Just
one
a block
block.
names,
Okay.
assume that just
Hmm.
address.
Hmm.
Then as and when a 10 is are fixed, it might have created a C1 to C15. Okay, then
Okay.
it will copy B1 to B10 into this one.
Hmm.
Okay, and the remaining elements are going to be used for you. That means
Okay.
initially when you declare your array list, it has created a memory blocks from B1 to B10. As
Okay.
you reach that block, so
Hmm.
instead of extending that memory, it's
Hmm.
creating a altogether a new bigger room for you, which is called C1 to C15, and then B1 to B10 are copied to C1 to C10, and the remaining 5 elements are being used as additional. You got it?
Okay.
You are shifting to
Okay.
new house.
Okay. It is not extending the same memory space. It is creating a new one, new
Exactly.
place. And
And
okay.
you are shifting from second floor to third floor.
Okay. Okay. By default, it is doing that. No need to do anything for
You
us.
know,
Okay.
don't need to do, but the effort you need to take. So if it's 10 elements, that's fine. Let's say
Hmm. Hmm.
if it is 1000, so
Hmm.
so if you're incrementing some more, what happens? All 1000 elements are moved to the another new block, and then it's going to perform, right? That means
Hmm.
whenever you add something, if it is reaching upper limit, it keeps on
Hmm.
doing this. So
Hmm.
that's copying, it's taking some consumption, right?
Hmm.
That's how it happens internally.
Hmm.
That happens whenever you add an element.
Hmm.
When you are adding an element, it takes this reference, and this is how the size is calculated, and it performs the reallocation.
Hmm.
But if you know the size in well advance, I know I need only 1000 blocks. You give 1000 size until 1000 you reach. Initially, B1 to B1000 itself is created for you.
Okay.
Then there is no shifting of operation is required, right? Until you reach 1000.
Okay, okay, yes, yes.
Okay, once you cross 1000, let's say, then once you cross 1000 and you are willing to go 1001, so it's going to create you 1500 blocks.
Yeah.
Then those thousands are going to be copied to new 1500 block, and the 500 blocks are going to be given to you.
Okay.
Okay? That means array list. Okay, this is for adding a element which happens. Okay, this is how the adding algorithm logic is built, because though collections we are representing, array list logic is completely based on the arrays. Means internally, if you open Java code of array list, it is having an array internally.
Okay.
So it's ultimately an array internally.
Okay.
So it has created some API called ArrayList, in which it's created a lot of methods to make it a like utility kind of a program for you. Okay.
I didn't get you. I didn't get you.
ArrayList internal implementation is an array. Means
ArrayList. Okay. Internal implementation is array.
so
Okay.
when you store some elements in ArrayList,
Okay.
it is going to store elements in an array.
It is going to store elements in array. Okay.
Array, exactly. Means whatever you are performing an array list, it is internally performing an arrays, which is some kind of a program internal logic is being written inside this Java class to handle that.
Okay. Okay. So ArrayList is extended from array?
Not extended. Internally it is using array.
Internally it is using array. Okay, okay.
When you say extend, that's altogether different. Means parent and child relation.
Yeah, yeah.
So let's say you are writing a program, internally you are using some variables, right? Array list is using in the array variable, array type of variables internally.
Okay.
Got it?
Got it.
So whenever you add an element, it keeps it's an internally array means it's an index based, right? When you add a first element, it will be at the location. So it keep on incrementing the array. Index is going to be incremented internally accordingly it stores all the elements, right? So these are the adding elements. So when you retrieve an element, so the method called get method to retrieve an element. Okay. Whenever you ask for a get, it gives you element 8. If you know the index, if you ask get, give me so and so element, it's going to give you. Take same number of seconds whether you ask for a first element or the 1000th element. Means like let's say if you are assuming 5 seconds.
Okay.
Ask for the first element is going to take only 5 seconds, or if you ask the 1000th element also, it's going to take 5 seconds. That means best suitable if your operation is more like in the get operation if you are going to perform.
Okay.
This is suits for the requirement, let's say where you wish to store, like you wish to retrieve many times. The retrieval operation is faster.
Here retrieval okay, option is faster.
Retrieval operation is faster. You have 10,000 elements. So your requirement is I need to retrieve I need to read many elements from that array list.
Okay.
I want first element first, like maybe 100th element, maybe 1000 element, I want 500 element. I'm looking for continuously reading something from the array list.
Okay.
So there is a book in that book I would like to read continuously, right?
Randomly.
Yeah, I'm trying to read it continuously. So that's why retrieval operation is more faster. Like whether you read the first page or 1000 page or middle page, no matter like which page you are reading, the reading operation going to take same time. Whereas adding operation, if you observe, if you are adding 1000th element, so 1000 times it has to copy internally. On an average, it will take 1 second, 1000 seconds, right?
Okay.
It's a rough calculation. It's not going to take that much time because it operates on the millisecond. But the for our convenience, we are giving that example.
Oh, okay. Understood.
So it has to perform a shuffling operation, everything. It has to deal with it. That's why it's going to take that much time. If you go for the retrieval means fetching of an operation. It's more faster because at any point of time it takes the same amount of time for reading.
Addition, it's a very fast.
Retrieval is the faster.
Yeah.
Okay, and when you try to delete an element, deletion is also slow. The reason is we have 1000 elements. Okay, so if you delete a particular element, let's say 10th element, what happens? 10th element is going to be removed. As I told you, internally it is based on the arrays, right? One second.
Okay.
Hello. Sorry. Clear, right? Add and retrieval. Deletion. Let's say if I delete 1000 elements, and if I try to delete any element in between, let's say if we take a 10th element, so we were deleting successfully. So what happened to that 10th block in the memory? We know it is an array, right?
Yeah.
So the 10th block will be empty, right?
Yes.
Usually array means doesn't do anything because this is ArrayList that is created for us, the Java guys. So 11th element is going to be copied to 10th. 12th is going to be copied to 11th. Like that, all elements are going to be moved one item in front of it in the previous block.
Okay.
So that the last element is going to be made empty for you. So that in future, if you add an element, it adds the element at the last.
Okay.
So it has to make a room for you at the last. Even though it deletes something in the middle, it's a shuffling operation.
Yeah, it would shuffle one block.
Got it, right? So the more the number of elements, the more the number of shufflings as well.
Okay, but as adding an element or
Adding element adds at the item at the last.
no. Just what you said is adding the elements are it takes very less time.
No. Retrieval I told you.
Okay, retrieval. It's very fast, that operation.
Yes.
But deleting is a bit slow.
Deleting, adding, apart from retrieval, every operation is slow.
Okay, only retrieval is very fast. Okay.
Yes, adding, so it has to allocate a memory if you are crossing the boundaries, and lot of shuffling has to be, lot of copying operation has to be taken, right?
Yeah, first it would copy the before size.
Yeah. And the retrieval, it's no matter, like if you know the index, it's going to be the same.
Okay.
And the deletion, if you delete a particular element, for us doesn't make any sense, but internally it requires a shuffling so that it makes your last room empty for the upcoming elements. But I'll just show with a small example. All these are from the package java.util package. So it's on the java.util package. So ArrayList has direct add method. So add takes an object, so we can add any kind of an object. System.out.println is going to display all the elements if you observe, but it display everything in a single line.
Okay.
Got it?
Okay.
So if you want to remove a particular element, so what we'll say? Remove method. So I would like to remove particular index. So index starts from 0, right, in Java? 0, 1, 2, 3, 4. So let's say I'll say third index. Third index when we remove should have 0, 1, 2, 3. 800 is removed, right?
Yeah, 800 is removed. Okay.
Remove. Like that is when remove. So if we want to know a particular element, simply I can say start get operation. So you can ask for any element, third index. What is third? In this time, third is maybe 200, right? Right? So here, if you observe, insertion order is preserved. Like the way we have stored the elements, the same way we are getting the elements, right?
Yeah.
Stored 100, 500, 300, and accordingly, there are some collections like where insertion order is not preserved. So even though you store in some order, it will store in a different way. But ArrayList is based on the arrays, right? Storing elements in the order like one by one at the end. So obviously insertion order is preserved here.
Got it.
Okay. If you want to know the size of elements, simply we have a size method.
Size of that.
So there is a requirement that we might need to know the total number of elements, right? So we just go for the size. I'm going to give you the size. So this is the first kind of a like default implementation. If you're not mentioning any size, let's see if we mention it. Here you ask, here the initial size is 10. So what is that initial size? We call it as a initial capacity. So let me print that capacity. The terminology perspective, we call it as a capacity. Capacity is not available directly. There's some. Let's say 20. Now this time the room is given 20 blocks are created for you. Still, the overall operation is like the still the size. This size is going to give you the only the number of elements available, right? This size doesn't have a reference to this one. This is the number of blocks which is created for you, the size which are given.
Oh, just we created, but the actual number of elements we do have, it gives only that size. Okay.
Yes, obviously, right? Otherwise, so you might be having many number of blocks, but out of that, how many blocks which are occupied, that I need to know. Then I will be in a control that I might still am having so and so number of rooms available, so that I can store the remaining elements into those unused blocks, right?
Yeah.
Okay. This is how the ArrayList works. So if you go for the vector, this is the latest version, which is in the like 1.2 version of Java, and the vector is like 1.0 version, which is called the legacy, older version of it. Okay. This is
vector
also
is the older version. Okay.
yes. The vector, ArrayList, LinkedList are the implementations of the list interface. Okay.
Okay.
This is called interface. This is class. This is class. This is class. Okay. So we just seen one implementation about the ArrayList, and the vector is another implementation, which is an older version of it. Okay. Main difference between the ArrayList and vector is vector is also follow the same style of representation. That means the same way it stores internally the way of representation of arrays. So whatever we discuss the points here with respect to ArrayList, way of storing, way of retrieval, adding, removing elements, same way it performs in the vector as well. The primary difference between these two is vector is synchronized, ArrayList is not synchronized.
Okay.
You remember what is synchronized?
Synchronization. Yeah.
So when we say synchronized, anything is synchronized means only one person can access that at one time, right?
Okay.
You might have seen synchronized block, right?
Yes, we about that.
So vector, we are saying that vector is synchronized means. So if you are working with a concurrent programming, in that if you declare variable as vector variable which is after vector, because vector has a synchronized nature, obviously if any person any thread is accessing that vector object, working on that vector object, even though another thread requires the same vector object, it has to wait because someone else is already using that vector object because of the synchronized nature. Got it? That means concurrent activities are not possible. Let's say you are writing a gaming kind of thing. So there might be a program which is going to calculate a scoring. So scoring calculation, when the scoring calculation is performing, maybe something should not be done, assume. So until the scoring action is completed, you cannot proceed further. So the scoring action is in the form of a synchronized block. If you declare those kind of activities with respect to vector kind of a implementation, then that is going to be executed only one thread at a time. So until that is completed, you cannot proceed further. Got it? So if you want to go for synchronized behavior, then you need to go for the vector.
Okay.
If you want to go for the non-synchronized behavior, then you need to go for ArrayList. And both of them internally storing items based on the arrays format.
Okay.
Got it?
Understood.
Yeah. So I'll just copy the same program. It's almost same. It's also having same methods as that of the ArrayList because all these methods are from the collections and list. Collections is also one of the interface and list is derived from that interface. So all the methods whatever we are referring to, add, remove, size, and all these are from the not from the ArrayList actually. So those are from the those specific kind of interfaces. Okay. Here the vector. Vector. So I just left the name as it is, but ideally this is not good programming practice. You need to give the proper name when we are doing in the real time. So rest everything is same, right? Or just change the same name. When you run, you'll expect the same kind of result, right? There was no change at all.
Yeah.
Only implementation perspective, internal implementation same. Only thing that synchronizing, non-synchronizing behavior. Rest everything, and also one more primary difference. The major difference I forgot to miss. I missed. ArrayList, how many blocks it allocates?
What the specified blocks?
Yes, when you initially it allocates 10 blocks, right?
Oh, initially, okay, by default.
Yes, when you reach the 10, immediately it makes you 15, right?
Yeah.
So, but vector initially 10, as and when you reach the 10, it makes you 20. It doubles it. This guy makes 50%. This guy doubles.
Okay.
Okay. So if the 1,000 blocks are there, it's going to make 2,000 blocks.
Oh, ArrayList it's going to make half, and vector it's going to double.
Yes. Half is a tentative size. Okay. This is going to be 100% size.
Okay.
Okay. But problem here is, let's say you have 10 elements.
When we won't specify the array size only, then it will give the 10 default 10 size, right?
Yes. When you specify the size, that is going to be initial size. From there, it calculates the remaining logic.
Okay.
Let's say if you given 1,000.
Okay.
Okay. When the 1,000 are filled, so then what is the double? So 1,000 into 2,000, right? You see 2,000 blocks here. Let's say you have 10 blocks. The default capacity, when the 10 blocks are filled, but your requirement is only to store 11, assuming that, okay? Because you are using, suppose ArrayList, it gave you 11 blocks. It has created 15 blocks, and out of that you stored 11th element, and you are fine. Only 4 blocks are wasted, right? If you do the same thing in vector, when you reach 10 element, it gave you 20 blocks. Though your requirement is to store only 11th, 9 blocks are wasted, right? So ArrayList is far better than the vector, right?
Okay.
So here example I took as 10 element. I assume that if it 1,000, how many blocks you are going to waste here, right?
Oh, 999.
So it's all depends on that. Like each has like their advantage and disadvantage. All things based on the requirement, like which one to be used. But if you know the the understanding perspective, then obviously we can use that. As of now, we know that if you want to store on the different individual objects, so if you want to store them, and then the insertion order should be preserved, and I want my elements to be stored in the size appropriately. Means like if you want to store the double the capacity or the individual capacity, 50% of capacity, so you might be having a requirement, right? So accordingly, it might be, and you are looking for synchronized nature or non-synchronized nature. Vector is synchronized, right?
Yes.
ArrayList non-synchronized. So accordingly, you can pick for all these elements.
Okay. So most of the time, depending on the requirement, or we do use ArrayList?
Depends on the requirement. Whatever the requirement you have received, based on that, you need to compare with these properties. First requirement. So whether it's you are required synchronized or non-synchronized, there itself, first point it filters, right? If you're looking for synchronized, definitely whatever is the case, whether you care about the memory locations or what, you need to go for this one, right? If it is
synchronized vector,
right? The main difference is these two, and apart from that, memory location, and rest everything is same, right?
Okay.
You need to focus on only the memory allocations and the synchronized nature.
Okay.
Just all like adding, removal, fetching, and everything is going to be having the same behavior with respect to speed and the performance and everything. Okay. When we say synchronized, obviously performance-wise, vector is bit slow, because when we say synchronized, only one guy has to work. So only one guy has to work means one guy one by one has to complete his task. So obviously it takes more time.
Oh yeah.
But this guy, it's not synchronized. Multiple guys can talk to him and do the things. So things can complete much faster.
Okay. Okay. Understood.
Right. Now got it. ArrayList and vector.
Yes, understood.
This is based on arrays and this is based on arrays. Okay.
Okay.
We have seen the similarities and the differences. Now the next one, linked list. Linked list is also to store the similar kind of like if you want to store the elements, individual elements and all the things, but you do not want, like here the internal mechanism is not based on array. Internal mechanism is based on the here. This is based on the double linked list. You know the data structure.
Oh yeah.
You might have studied in the C or C++.
Studied just for, yeah.
Double linked list is like not specific to Java. This is a general data structure concept. So the main thing how it refers is like for every element that we are storing in generally, that particular element is going to have the address of the previous block and have the address of next block.
Next block, yes.
Right?
I do remember.
So it's a kind of chaining, linking.
Yes.
When you talk about the next element is going to have the address of my element and obviously his next element.
Next element, yes.
So if you visualize that picture and if you consider for like, let's say if you want to like add an element to the linked list, what happens here? It is going to, whenever it add an element, it just adds an element, creates a new block with these slots, like with 2 memory locations and 1 with the data value. It copies. Like when you try to retrieve an element, assuming that you have 1000 elements in the linked list by connecting with this link. Okay. So I wanted to retrieve 1000 element. So what you have to do? Do you know the 1000 element address?
No.
So who is aware of the 1000 element address? 999 guy.
Yes, yes.
So how would 1998 guy? So 998 like that.
Oh yeah.
Nobody knows the direct one. So only the adjacent guy knows his address. So that means
yes.
if I need to read the 1000th element, so I have to start from the first element. I have to talk to each individual guy. What is the next guy address? Next guy address like that. I have to traverse till the end. Here, the retrieval operation is more consumption than the. Got it? The difference?
Yeah, got it.
In the ArrayList and vector,
time, right?
yes, ArrayList and vector, you know the index. We give 1000, it gives you 1000 index value directly. So, but here it doesn't based on the indexes. It's stored and based on the array
address.
Double linked list. So directly cannot talk to particular element. It has to be gone through this one by one in the sequential order. Got it? So retrieval operation is not faster like because of the dependency between the previous elements. But the adding and the removing elements is very easy. Like the remove, let's say if I want to remove, let's say 1000 elements are there. I wanted to remove 10th element. How do we remove? Simply, I'll just remove the 10th element. So when I say, let me say, I'm saying 10th element. Obviously, I'll be having 9th element here,
Yeah.
11th element here, right?
Yeah.
When I need to remove 10th element. So this 9th element is having address of
9th one,
address of 8th element and 10th one, right? And this 11th element is having address of 12th element and the 11th element. Agree?
Yeah.
So now I am planning to remove 10th one. So right now 9th is having 10th value, 11th is having 10th value. What I have to do? I have to just remove this guy and I have to connect these two. Means 11th address has to be stored in 9th and 9th address has to be stored in 11th. That's all.
Oh yeah. Okay.
So you just remove only one link. Means because each and every block is going to have the 2 address blocks stored. Means previous block address and the next block address, right? 3 slots. One is for actual value and left side and right side blocks are for memory location preferences.
This 10th is having its memory address in 9 and 10th is having 11th address, right?
Yes.
Okay, it is having its own and okay.
So any element, if I take 8th, if I take 9th, 9th is going to have the in the each and every cell that we are talking about, it is going to have 3 blocks internally. It's difficult to draw here. Let me open. right? So when I say eighth is not one single element, internally having 3 blocks.
Yeah.
In this, it's going to store the 7th element address, and this is going to store the 9th element address. When I say 9,
Okay.
so in this block is going to store this 8th reference. In this block
Okay.
is going to show 10th element. Remember, 10th element is going to have 3 blocks internally. So one is to store the previous guy address, that is 9th, and this one is to store next guy address. So now if I want to remove 9th means, so right now this block is going to have the 9th address, right? First,
Yeah.
in this one, I have to take the 10th address and store the 10th address here.
Okay.
Right?
Yes, yes, yes.
In the 10th, right now, this block is having 9th address. So what I have to store 8th address into this one. So that means you have removed your chain.
Okay.
Not your chain. Just you are creating that link and you are establishing a relationship with other links.
Oh yeah.
Perfect.
Understood. Understood.
So here, advantage here is whether you deal with 1,000 elements or 10,000 elements. If you want to remove 9,000 element location element which is there at the 9,000 location, so simply go to that element, just remove that element. So it doesn't take much time, right?
Oh, okay. Okay.
Whereas in the ArrayList and vector, you're working based on the arrays. So shuffling operation, everything takes a lot of effort.
Yeah, it will shuffle each and every element. Yeah,
Exactly.
yes, yes.
So when your operation is adding, the deletion operation is more frequent, then you need to go for the linked list. Okay, where deletion updations are the more frequent, then you need to go for the linked list. And more suitable for the retrievals. Got it? All
Okay.
depends on like which case. So I'll just copy that. You're getting error observed here?
Yeah, 20.
In the linked list, you cannot give any size because it automatically allocates as per the. Can you give? I want this many blocks. You cannot give, right? So, as many number of like as and when you establish a link, it creates a block for you. Whereas in the vector and arrays are based on the arrays, right? So it internally for us arrays has some kind of memory allocation, but this is based on the double linked list format. So when you are working the double linked list, you are not going to give a size.
We are not going to give the size.
Yes. In fact, it won't allow. All right.
Understood.
So, any doubts on these topics, like whatever we discussed today?
No. Everything is
okay, Artha, I think we are good for today.
Yeah.
And we'll continue tomorrow with the remaining topics.
Okay.
Thank you. Bye.
Bye. Good night.